Okay, I guess we'll just go on with this. I thought that I had done a math lab where I solved some nonlinear equations on math lab, but what I did was I did some from 8.5 where you have to shade the inequalities because they're a little weird, but these are not that weird. So um, the ones in 8.5 are the ones that are so weird. So we're going to solve algebraically using either substitution or elimination or a combination. And then we're going to look at solving them graphically. So if we talk about systems of nonlinear equations, then what we're going to be talking about here is equations that are circles or parabolas or something like that. So two examples here. Um, this one, so this is x squared equal 2y plus 10. When you see a y to the first power and an x squared, that's going to be a quadratic. Because you could rearrange that and you could write it in terms of y equals some x squared function. So anytime you see an x squared and a y to the first power, it's going to be quadratic. Now this is a line. So this is linear. This is quadratic. And this is a circle. So anytime you see x squared, y squared, you're going to be graphing a circle. Now, this is the section you might need some help with. So what I want you to do before next time is after we go over this section, I want you to do your math labs and bring questions to me because students do have some trouble with doing this section in math lab. Because I can't give you an example of every nonlinear system of equations that you might have to do. So you may see some that I didn't do an example like it. There's no way I can just pick all the different types that you might get. You might get an absolute value in a circle. You might get a parabola in a circle. You might get two circles. So I'm going to do the best I can to go through as many examples as I can, but you may have to write down your questions and ask me to go through those the next class meeting. And that's not a problem. That's what I would like for you to do. So when we finish going over this section, I would like for you to try to make sure that you've done the math lab for 8.3 by Tuesday so that if you do have questions, I can work those out at the beginning of that class. So let's start with this one. That's one of the first examples that was written there. So like we said, we know this is a quadratic, and I'm not going to do graphs on all of these, but I will do graphs on some of them. But this is a quadratic, and this is a line or linear. So I would use, when I've got one function that has an x squared and a y, and the other function is just linear, I would solve the linear function. So if you're dealing with a one linear, and one nonlinear, then we want to solve for y in the linear equation. Because it's easy to solve. So, and we actually could solve for x too, but it's easier to solve for y in the linear equation and then substitute. So anytime you're dealing with one linear and one nonlinear, we want to solve the linear for y and then use substitution. So that's where I'm going to start. I'm going to take the linear equation and I'm going to solve it for y. So I'm going to move the 3x term over. And then when I divide by -1, I get y equals 3x plus 9. So let's look at the other equation. Now I know what y is, so I can go substitute it there for y. So now I'm just going to substitute for y. So in place of y, I'm going to put 3x plus 9. Then I'm going to use the distributive property. And then I'm going to combine like terms.
Miss Rachel.
Miss Rachel, wouldn't it be minus 9?
She's not the rental agent.
Could you divide
Yes,
one?
it would. Thank you. Thank you for stopping me. Yes. Because I was about to make a mistake. Thank you for stopping me because I didn't divide by -1 here like I should have. So that should be minus 9. Thank you so much. That was going to make a mess if I didn't fix that. Okay, so now when I combine like terms, that's going to be minus 8. Now, what do I do when I have an x squared? Anybody know? Got a x squared term, that means something. What does it mean when you see an x squared? It means you have to do what? I know somebody knows. Can you solve it like that? Yeah, so we need a factor. So what we want to do is we want to set that equation equal to 0. So I'm going to recopy it on my next page. So that means I need to move everything over to the left so that this side is 0. So I have x squared minus 6x plus 8. And I can factor that because I can multiply to get 8 and add to get -6 if I use -4 and -2. -4 times -2 adds to give me 8. I mean, multiplies to give me 8, but adds to give me -6. That's what I want. So now I have x equals 4 and x equals 2 when I solve those two factors. So set the two factors equal to 0. And solve for x. So you get x equals 4 and x equals 2. Now let's go back where I solved for y. When I solved for y, after I got the correct y, it was y equals 3x minus 9. So I'm going to have two intersection points, is what this means. So when x is equal to 4, I'm going to plug in x equals 4. And I'm going to get y equals 12 minus 9 is 3. So my first ordered pair is 4, 3. Then when x equals 2, that's -3. So I have two solutions. And basically what that means graphically, and this is just for free here, basically I've got a line that goes through here, through these 2 points, and I also have a parabola that goes through those 2 points. And that's the 2 places where the line intersects the parabola. Now, you don't have to draw that on this problem, but at some point we might have to draw this. So we've got to be able to graph the parabola and the line in order to find that intersection point. But that's how you do it algebraically. And this is what it was, something like what it would look like on the graph. You would have a line going through these 2 points and the parabola also going through those 2 points. And those 2 points would be the solution because that's where they intersect each other. Now, am I going too fast? Everybody understand what we just did? Anybody have a question? You can stop me anytime you have a question. All right, I'll go to another example. All kind of examples we could do on these type problems. This one looks very similar. This one looks like we've got a linear and a quadratic again. So you could do the same process again. This is a very common one, linear and quadratic. It's very common for me to put one like this on the test as well, because in nature or in certain natural processes, this is the one that occurs the most, is where you've got a line and a quadratic intersecting. Okay, so since I just did one, how about if I just let you work on this one for a minute? Work on this one algebraically and see if you can come up with a solution. And I'm willing to provide anybody, whoever's the first one to finish, with some bonus points. Like 2 bonus points on your next test. Oh, good. 2 of you got the same answer. And since I just looked, both of you get the bonus points. You're welcome. All right, so I'm going to work on this one. I could solve it the other way. I don't necessarily have to solve the linear equation for y, but normally we find that that's the easier way to do that. So I got y equals 4x plus 1. So I'm going to use that in the other equation. And in place of y, I'm going to substitute in 4x plus 1. So that gives me x squared equals 4x. Still have a quadratic, so I still need to set the equation equal to 0. And I still need to factor. So those are my two factors. I factor out only a GCF there because I don't have a constant. So this gives me x equals 0 and x minus 4 equals 0. And that gives me x equals 4. So those are my two x values. So I'm going to plug each one of those in to the y. So one of my answers is 0, 1. And then I'm going to plug in x equals 4. So I get y equals 17. So those are my two solutions, 0, 1 and 4, 17. Okay, so let's go to a little bit different one. Solving, again, I would use the linear equation and solve that. And then substitute in. So one of these is a line and one of these is a circle. And you have to remember back to your circle if you wanted to graph this, which I am going to graph it, even though you might not need me to graph it. I'm going to graph this one because I want to remind you how to graph a circle. So what I'm going to do is take equation 1, which is the linear equation, because I just have an x and a y to the first power. And I'm going to solve it for y again, just because I tend to solve things for y rather than x, but you could solve for x too. It wouldn't matter. So I'm going to divide everything by -1. So y is x plus 3. Nope, did it again. Y is x minus 3. So I'm going to write my circle equation over here. And inside of this parentheses, I'm going to replace y with x minus 3. So I'm going to use a double set of parentheses here for just a minute. Plus 3. So I'm just showing you that inside of that parentheses, this was y. I'm going to substitute x minus 3. So that's going to give me x minus 3 plus 3. So that's just going to give me an x squared left there. So x minus 3 plus 3, when I remove those parentheses and combine like terms, I'm just going to have an x squared left there. Now I need to FOIL this one out. So when I do x minus 2 squared, that's x minus 2 times x minus 2. And I'm going to shortcut that a little bit. I'm just going to do it in my head. So it's x squared when you do the distributive property or the full method, that's what you're going to get. So again, I'm going to have quadratics. So I have 2x squared plus 4x minus 4. So I need to get this equal to 0 again. Okay, hopefully y'all are keeping up with my work. Have I done anything wrong? Made any mistakes here? I think everything's good. So I need a factor. And so I'm going to copy this over to another page. And so I won't have to jumble all this up. This has a GCF, so I don't want to try to factor that before I factor out a 2. So I factored out a 2. Now, I see a problem here. This won't factor. There's no way to multiply to get 4 and add to get -2. So when I see that, the first thing I'm going to go back and I'm going to check my work again and make sure I did everything correctly on my work. It's not to say this couldn't be right. I just want to double check everything since it won't factor. Okay, so I think I'm correct here. So when it won't factor, the only way I can solve is now I can go ahead and divide both sides by 2 here and get rid of that 2 that I factored out because it's an equation and I can do that. So when I divide by 2, this is the quadratic equation I need to solve, and I can't solve it by using factoring. So I'm going to have to use the quadratic formula. So negative b plus or minus square root b squared minus 4ac over 2a. So a is 1, b is -2, and c is -4. So I'm going to put a negative of -2 here. So that's going to be a +2. The opposite of b there is the opposite of -2. And then -2 squared using parentheses so I can square that negative. So I'm going to go over here to the side and do the radical. So I don't like to keep carrying that stuff around. So that's going to give me 4 plus 16. Because that's a negative and that 4 is a negative. So that's minus -16. So that's plus 16. So that's the square root of 20. So if I break that down into the perfect square, 4 times 5 is 20. So that's 2 times the square root of 5. And then I can separate that into 2 terms, plus or minus. So 2 plus or minus 2 square root of 5 over 2. So that's going to be 1 plus or minus square root of 5. That's x. So my two x values are 1 plus square root of 5 and 1 minus square root of 5. Then if I go back and see what I got, y is x minus 3. So I'm going to go to this next page. Y equals x minus 3, and I said x equals 1 plus or minus square root of 5. So y equals 1 plus square root of 5 minus 3. So that's negative 2 plus the square root of 5. So that's the y. And then I've got to plug in this one. So that was for x equals 1 plus square root of 5. So now I'm going to plug in x equals 1 minus square root of 5. So my ordered pairs, 1 plus square root of 5 for x, negative 2 plus square root of 5 for y. 1 minus square root of 5 for x, negative 2 minus square root of 5 for y. Those would be your answers, and I'm pretty sure you have to type them in like that into MathLab. Now that was a pretty lengthy problem. Did I go too fast? Does anybody need me to go back to any of the previous slides? Anybody need me to go back to any of the previous slides? All right. That would be considered one of the more difficult problems. Now, graphing this one, this is what that would look like. If you've got x minus y equals 3, you can graph that using the x and y intercepts. So if I use the x and y intercepts, I set x equal to 0 and I get negative y equals 3. So I get y equals negative 3. So the y-intercept is 0, negative 3. Then if I set y equals 0, I just get x minus 0 equals 3. So I just get x equals 3. So 3, 0 would be my x-intercept. So you would graph the x-intercept and the y-intercept and draw a line through it. And then the circle equation was x, I believe it was, let me go back and look at I forget what it was. X minus 2 and y plus 3. So the center of this circle is 2, negative 3. Remember, we changed those signs. And r squared is 4. So r is the square root of 4, which is 2. So I go to 2, negative 3. And then I count out a radius of 2, up, down, right, and left, and get those points and draw my circle around those points. So that means I did do something wrong in my problem because this was the solution. The solution was 0, negative 3, and 2, negative 1. So did anybody find an error in my work up there? Because I had to have made an error. Looks like I would have checked that. I didn't realize I already had the solutions down. So somewhere along the line, I've made a mistake and I've got to go back and find it. So how about if I just go to another problem for now, and then I'm going to convert that problem, because sometimes when I don't look at it for a while, I can come back and figure out what I did wrong. Now, what do you think we might want to do with this one? This is 2 circles. We used substitution when we had a linear equation and a parabola. We used another method, the method of addition or elimination. We used when we had 2 linear equations. So we might want to try that when we have 2 circles. Well, actually, we don't have 2 circles. What we actually have is an ellipse and a circle. Because if there's a number out in front of this x squared, so this is going to be an ellipse, which we don't study ellipses, or we don't really graph ellipses in here. But what we do is we can solve these algebraically. So this is a circle and an ellipse. But I can use elimination here. If I multiply this bottom equation on both sides by -1, I'm going to bring this one over. Probably something silly like that on the other problem that I did wrong, just bringing something down wrong. So I'm going to take this one, and so that I can cancel out my y's when I add, I'm going to multiply both sides by -1. Now, when I add these, that gives me 0 for y, and I have -3x squared equals 3. If I divide by -3, I get x squared equals -1. That's not -3. Guys, I don't know about me today. Sorry, all I can tell you is I don't know what I keep doing, but that was not a -3. That was a +3. 4 minus 1 is +3. So x squared equals 1. So if I take the square root, I get x equals plus or minus the square root of 1. So x could be 1 or -1. So we got to plug that back into one of the equations and figure out what our y is going to be. So I'm going to take the x equals 1 and I'm going to plug it back in to this equation. So that's going to give me 1 squared plus y squared equals 10. So I'm going to subtract 1 from both sides and I get y squared equals 9. So if y squared equals 9, then that means y equals square plus or minus the square root of 9. So y could be 3 or -3 when x is 1. So how many solutions does that give me? When x is 1, y could either be +3 or -3. So that's 2 of my solutions right there. This is going to give us 4 solutions. And we'll look at a picture of that in just a second. But I'm going to go to the next page because now I need to use x equals -1. So now I need to use x equals -1. So I have x squared plus y squared equals 10. I just like to choose the easier one to plug into. So I'm going to plug in a -1 in parentheses. And I'm going to work this out the same way I did the other one. So I get y squared equals 9. So y is going to be plus or minus the square root of 9. So y is going to be 3 or -3 when x is -1. So those two solutions are -1, 3 and -1, -3. So it's real important that you get all 4 solutions, and I'm going to show you why. So we had in the first set of solutions, we had 1, 3 and 1, -3. Then we have -1, 3 and -1, -3. All 4 of those are intersection points of these 2 problems. Now, do I need to go back over any of that? I had made a mistake earlier. I knew I wasn't supposed to be getting a negative answer or an imaginary answer. So I'm going to go back and make sure you got that. So don't do your problems like I have. Don't go through there and just haphazardly work these, because if you do, you're going to come up making a mistake like I did and mess your whole problem up. Okay, so this is just where they did what I did, where they back substituted to get the X and Y values. And then I want to show you what this picture looks like and why you have 4 intersection points. So you see the circle and then you see the ellipse, and they cross each other at those 4 points. Now, in this course, we don't teach you how to graph ellipses. We teach that in 113. So you're not going to be expected in Math Lab to actually graph one of those because you don't know how. But what we can do is look at a picture of that's just what I wanted to do, was take a minute and look at the picture of what that would look like on the graph. All right, so this is a similar problem, except this time we have 2 ellipses, but you're going to work the problems very similar to the way we worked, except for in this one, you're going to have to multiply both equations by something. So my suggestion would be to multiply maybe this equation by maybe -2, and maybe this equation by, -3, I'm sorry, and maybe this equation by -2, by +2. That's what I'm trying to decide, but I think that's what I would do. One of them just needs to be negative, because what I'm trying to do here is eliminate these y terms in the middle. So if I multiply the top one by -3, I get -6, and the bottom one by 2, I get +6. Then I'm going to eliminate. So while I go back and fix my issues on problem number, the previous problem that I made a mistake on, I want you to try to work this one and see if you can come up with the solution. I'm going to go back to the one that I made the mistake on earlier and find my error there so we can correct that. Yes. I just found that, Rachel. Thank you. Made the problem a lot easier too, didn't it? All right, Hannah, you're racking up these bonus points. Y'all just, if you're working, just keep working. I'm just going to go ahead and multiply this out and necessarily finish the problem. Okay, so did everybody get that? If you were working it out, did you find that the x was positive or negative 3? Good. So then you got to pick one of those equations, and neither one of them one doesn't look any easier than the other. So I would just pick one of them and plug into it. It doesn't matter which one because, like I said, neither one looks any easier than the other to plug into. So I'm just going to plug in x equals 3. I'll just use the first equation. So I'm plugging into equation 1. Okay, order of operations, square the 3, then multiply by 3, you get 27. Subtract 27. Solving for y, we get 4. Y squared is 4, so y is going to be plus or minus the square root of 4. So we're going to get y equals 2 or negative 2. So when x is 3, we get 2 and we get negative 2. Now, notice when you got a 3 or a negative 3 and you're plugging it into the square, you're going to square it. You're going to get the same answer. Does that make sense, what I just said? If you plug in a 3 or a negative 3 into x squared, when you square that, it's going to be a positive 9. So even if I put a negative 3 right there, for the second part, when I square it, it gives me 9. 9 times 3 is still 27. So without going through those steps again, you're going to get the same answers for y that you got when x was positive 3. So you're going to have negative 3, 2, and negative 3, negative 2. Now, when you're working this out for me on the test, it's okay with me if you do that. As long as you show me one of them, then you can extrapolate that if you're squaring that, you're going to get the same answer for y that you got when you put in the positive 3. But I do need to see one of those. Any questions on that? I'm going to go back to that problem that I messed up a while ago and fix my errors there. I'm not glad that I messed up, but I'm glad that I did show you that sometimes you do have to use the quadratic formula because everything doesn't come out to be factorable. So what I did right here was when I fold this out, I took a shortcut and I messed up because that's a positive. I should have just gone ahead and done the work. So x squared minus 2x minus 2x plus 4. So there's where I made my mistake right there. It's real easy to make those negative mistakes. I even do it too. So when I see you've done that on the test, I do try to be lenient and help fix that. So this becomes a plus, this becomes a plus. So this is a 0 right here. So the 4's cancel out to 0. Now I'm going back. This is the problem that I did that I got the wrong answer for. So this is the corrected version. So these two cancel out to 0. So I just have 2x, 4x left. So 2x squared minus 4x equals 0. Factor out the GCF, which is 2x, greatest common factor, and that leaves x minus 2. So 2x equals 0. X equals 0. And x equals 2. Now, when I first solved for y in that first equation, I got y equals x minus 3, I believe. So when x equals 0, then y equals negative 3. So 0, negative 3. And when x equals 2, y equals negative 1. So 2, negative 1. Those should have been the correct answers. I messed up on that I showed you. I'm still glad that I showed you how to do it if you couldn't factor it, because sometimes they won't factor and you just have to use the quadratic formula to solve. So for that part, I'm grateful, just not for the part where I messed it all up. All right, so this next one is already worked out. This one is where elimination was used, I believe. And you can do it this way, or you can use substitution. Doesn't really matter which way you do it. Circle sitting on the top of it. That's a good one that for graphing purposes. Do on this, take this and substitute it right there into the y squared instead of the way they did it. I don't know why they did it this way, to be honest, do it this way. I would just substitute into that. So how about if I just work this out by what I think is an easier method? So since you have this right here, I would not take this and substitute in there. I tell you what I would do here is I would solve for x squared. I think that's actually what they did. They just didn't show it the way I would show you. Why would I not want to substitute into squared here? Substitute I squared, I'm going to get a fourth power. And that's not a big deal. You can work with a fourth power, but it's much easier not to do that. So I see what they did. They just did it with vertical, did some vertical stuff. I would rather do it this way. So you don't want to substitute an x squared into a y squared is what I'm saying to you, because what you're going to do is you're going to get an x to the fourth power. So solve this equation for x squared. And let's substitute for x squared instead of y. So if I subtract 3 from both sides, I'm going to get x squared equals y minus 3. And this is the substitution I'm going to make. I'm going to go to this equation right here, and in place of x squared, I'm going to plug in y minus 3. Now I'm going to rearrange everything, and I need to get the equation equal to 0. So I'm going to subtract 9 from both sides. And then I'm going to rearrange it to where I'm in the correct decreasing degree order. So y squared plus y minus 12 equals 0. Then we can factor, and we get y plus 4 and y minus 3. So this one gives us y equals negative 4. When we set those factors equal to 0 and solve, we get y equals negative 4 and y equals 3. So we can go back to any of these equations and solve. Doesn't matter which one. So I'm just going to use the second equation. Well, I tell you what, let's use the one we already have solved for x squared. Let's use this one. X squared equals y minus 3. So when y equals negative 4, x squared equals negative 7. So we get plus or minus the square root of -7. Imaginary number. So we're not going to see that in our graph. This is imaginary, so we don't use that in these problems. It is an intersection, but it's in the imaginary plane, in the complex plane, so we can't use that answer because of that negative right there. That's an I. That's I square root of 7, imaginary. So we can use when y equals 3. So x squared equals 3 minus 3, so x squared equals 0. So that means when I take the square root, I get x equals 0. So the only answer that I have for an intersection is x equals 0 and y equals 3. I can't use that one because it gives me the imaginary answer for x. It is a solution to the system. Don't think it's not a solution, but we're only talking about real solutions in this chapter because we want to be able to find the place sect on the graph. And that's why, because there's only one intersection point that you can actually see in the XY coordinate plane. Now, if we could go to the complex plane, we actually could see that. But we don't go to the complex plane here. We do that in 113 as well. Try that one. That one's very similar to the one we just did. Try that one. And then I think I might have one or two more that I want to try to get to today. So you try that one real quick. So Hannah got 4 bonus, so Hannah doesn't get the chance to get the extra bonus points this time. So someone else type your answer in when you get it. So we got another one with some bonus points. Good job. Does anybody need me to work? Victoria, you got imaginers for, so just remember you did that correct. You did that correctly. Just remember you can't use your imaginary answers, okay, for these, because we're only wanting just the real answers. So maybe I will just make a note of that when you take your test, that all we need are the real answers that actually could be put on the graph. Okay. But those are all correct answers. That's what I got as well. Shelby, did you say you need me to work this out? Okay, so again, form y equals plus 5. And if I substitute x squared plus 5 here, if I substitute it there, I'm going to end up with an x to the 4th because I'm going to be squaring an x squared. Try to avoid that. So what I want to do is take the y equals x squared plus 5, and I want to solve for x squared so I can substitute for x squared instead of for y, because I don't want to square x squared and get an x to the 4 to work. It could be a big deal harder. So here's what I'm going to do. I'm going to subtract 5 from both sides, and I'm going to get x squared equals y minus 5. So I'm going to go over here to this equation. And I'm going to substitute y minus 5 in place of now I see I've got a square term, so this is a quadratic. Can't solve that without factoring or using the quadratic formula. So either way, I've got to get this equation equal to 0. So now it's equal to 0. I have y minus 30 plus y squared, but I need to put it in order of decreasing degree so that I can factor it. Now I have it in a form that I can factor. So what multiplies to give us negative 30 and adds to give us positive 1? So it's going to be y plus 6 and y minus 5. So when I take y plus 6 and set it equal to 0, if I subtract 6 from y equals negative 6, y equals 5. Take these and substitute them back in place of y and solve for x. And because I have one more problem I'm going to try to work before we leave, I'm going to let you do that. But if you take a negative 6, you're going to get a negative 11. So when you square root, you're going to get imaginary. So this one's going to give you an imaginary solution. And we don't want an imaginary solution, so we just sort of throw that one out and we use this one. And that's going to give you, when you plug in y equals 5, you're going to get x equals 0. So that's going to be your solution. Does that help some? Okay. All right, so I want to work one more problem here today. This one is xy equals negative 12, and this is x minus 2y plus 14 equals 0. What you can do is solve, I would solve this equation for x. This one, which means I would add 2y and subtract 14. Okay, so I'm adding 2y to both sides and subtracting 14. So these two go to 0. Now I can take this 2y minus 14 and I can plug it in right there for x. That says xy, that's x times y. So I'm going to take 2y minus 14 and I'm going to substitute in place of x. So I have to distribute that y. And then I'm going to need to move the 12 because again, you can just imagine that on most all of these, you're going to end up with a quadratic. So you can't add 14y and 12, so you just bring it down. Now I have to factor again. Did I mess up?
Where'd you get 4y squared?
It's 2, isn't it? Thank you. Thank you. I don't know. Just in my crazy mind, some 2. So y times 2y and y times negative 14. I'm just glad I've got somebody keeping me straight here. I'm prone to make a mistake this time of the day for some reason. I guess I'm tired. No excuse though. I should not be too tired not to be making these mistakes. So factor out a 2 here because that's your GCF. Or you could just, you know what you can do right there is you can just divide everything by 2, but I'm going to factor it out. Now I would just divide both sides by 2 and get rid of that 2. You can do that once you have the thing equal to 0 and you factor, then you can divide that 2 out. Then we're going to have y minus 6 and y minus 1. So y is going to equal to 6 and y is going to equal to 1. And you can take those and plug it in. I would take it and plug it in right there where I already solved for x. So x, so when y equals, you're going to plug in y equals 6 and y equals 1. So when y is 6, x is going to be negative 2. And when y is 1, x is going to be negative 12. So 6, negative 2, and 1, negative 12. And we do have one more example that I would have liked to have worked, but we're out of time. So if you want to watch that one worked, it's in my video. If you go to the modules and you look at the chapter 8, section 3, video instruction for 8.3, you can fast forward all the way to the end of the video, and I have worked this problem out. And those are some review problems for you for this section. The book has terrible problems, so I chose 4 of them that are good. The rest of them are not so good, and then I just gave you that extra one there to work. So if you want to watch this one worked out, and I'll work it out again at the beginning of the next class, but if you end up with one like that, an absolute value in Math Lab, you might want to watch the end of that video and watch that one worked out. It's not hard. It's just you got an absolute value, so you have to deal with a positive and a negative equation for that. You have to do this. You have to say y equals 3x and y equals negative 3x. But I'll work it out at the beginning of the next class. I'm not sure if Math Lab gives you an absolute value one, but if they do, you can watch that on the video. It's at the very end of this video. And then here are some review problems for 8.3. I would suggest working review problems as you go along, just so you won't have to do it all at the end. If you review after you finish the section, you won't have to review test time. Okay, as always, email me with any questions, and even if you have problems with Math Lab, I don't mind you emailing me and asking me questions about Math Lab. I'm glad to help you. So please do that. Please email me and ask me questions if you have any.